Hello, good day and welcome to today's video, which is also the last video from my end. We still have one video from Abefe and one or two videos from Oyega. So in this video, we'll be analyzing, we'll be also working on a project, and this project is that of the data that is generated in the lab. So this is the data set, and then this is what the data set is about: water samples that are gotten from a river and from some streams. So that's what the data set is about. I got the data from this cargo page, and I would also share the link so that you can go through it. So this page actually just contain explanation about what the data is about. So okay, the entire data set is chronologically sorted, and then these three locations on these three sampling sites, they're actually located in the river, while these other two sampling sites are actually from two different streams flowing into the river. Okay. Why I don't know much about water analysis, this data set is actually suitable for what I want to teach, so we are going to be using it. This is the thing. This is the date the samples we are taking, this is the time, and this is the sampling point. Then the other samples we are taking to the lab, and in the lab all these values we are gotten by subjecting the sample to various necessary chemical tests. So for the meaning of the column headers, we have a data dictionary here that gives a bit of explanation about what the column headers mean. And I know that each of these variables, they have the acceptable limit. So that means that total chlorine content of a water sample from the river should be around a particular range, and then the hardness should also be maybe a particular type of hardness. Then there's this hardness here that is also a numerical value. That one should also fall into a particular range: the turbidity, dissolved oxygen, total suspended solid, total dissolved solid, electrical conductivity, and pH, temperature, and humidity. All of this should actually be within a particular range, and that is actually what the researcher can use to judge if maybe the water sample is actually good, or maybe it falls into the recommended criteria in the standard books. So, and for you to actually compare, you need to, because we several samples we are taking, what will actually be done is that the mean of the different samples will be taken based on the different groups. For example, we might want to know, because we took different samples from this particular location, we need to get an overall mean for that particular location, so that we can now use that overall mean to judge if that particular sample, if the water sample for this particular location, if it actually falls within the acceptable range and all of that. And okay, after judging if it falls within the acceptable range using the mean, then you can also compare samples from different location. You can compare samples from different location and see, well, maybe they are actually significantly different. Maybe a particular variable, maybe pH now, if it's significantly different across different location. So we are not actually doing much in this video, since I really don't have enough information on the acceptable range of all of these. But we know that to judge if it falls into acceptable range, we need to find mean first. So we'll actually be finding mean, and I believe maybe any student that is taking this class that have much more information about water samples can take the analysis higher and judge if samples from a particular location falls within acceptable limits and all of that. But for us in this class, we actually be finding mean basically, and then we want to also check if we'll be using pH. We want to check if the pH varies significantly across the different sampling points. So the first thing we want to do is to actually find the overall mean So we know all the samples are actually linked to a particular water body. We want to find the overall mean of these different variables for that water body. So I created this tab here that I called overall mean. And also, actually, when you are finding mean, you definitely should actually accompany it with the standard deviation, because standard deviation is actually what's going to tell us about the variability of the individual values for which we've actually found the mean. So for this ambient temperature now, for the overall mean now, we just use all of this data set here, and you can see that as I'm scrolling, I cannot see the column headers again. I want to actually see the column headers as I'm scrolling, so I'm going to go to view, and then here there's something called freeze pane that can help us with that. So freeze pane, and then I'm going to choose free stop row. So you can see there's a sort of line here. Now if I keep scrolling, I will always see the first row. So now I'm just going to come back here. I want to find the mean of this ambient temperature, so I'll come here and say equals average. That's the formula. And then yeah, and I can just select the whole column, and then that is the mean. And for the standard deviation, that will be equals to st dev, and I'll be using the one for sample because we are working with samples here. Then we need to just select everything. Make sure you select from the first cell, and then that is the standard deviation. You might want to make this mean 2 decimal place by reducing it, and then maybe standard deviation as 4 decimal place, or 3, and then that is that. So for the next one is basically the same process. You're using the average function, and then you need to select the variable. Make sure you select everything, and then you also want to actually get the what standard deviation. Now you will be using stdev.s, which stands for stdev.sample, because we're actually working with sample data. Okay, so for me now, I might to get the one for the next one. I know that sample temperature is in column F, so I can decide to copy this formula and then change the column to F instead of this E that is here. So if I change this E to F and change the other E to F, I've changed the cell reference in the formula. And if I press enter now, then this is now the mean for what, for the sample temperature. I can do the same thing for the standard deviation, but make sure you know what you are doing very well. We are going to be doing this so that you will not actually mess up your formula and then just get the wrong result, or get a lot of errors. So let's do, so it's basically the same process throughout to get for everything. But this, for me, this is quite stressful. So if you don't forget, we have the data analysis tab that can actually help us. So that's what I want to leverage now. So I'm just going to go to data, and then I'm going to go click on data analysis, and I will choose descriptive statistics. Then okay, then is asking for the range of the data. For the range, I'm just going to select from ambient temperature. Yeah, I'm going to select from ambient temperature to hardness, because I can't select this hardness classification because it is a numerical variable. I've selected my data now with the column header, so I need to check this place that okay, label is in first row. Then output range, I don't want it in a new worksheet. I want it, or let's say I don't want it in a new worksheet, so I'm just going to come here and then say I want it here. Then I want summary statistics, so I've checked summary statistics here. Then I'll just click on OK, and now I've gotten my results without actually needing to use formulas one by one. So we can see here the mean for ambient temperature is 16.64. Then we can see 16.64. The standard deviation here we got 5.164, and then we can see the 5.164 here. So this is how you can quickly get your descriptive statistics, getting your mean, median, standard error, and all of that using data analysis tab. Or also decide to get it by using formulas if like you actually prefer that. So after getting this your big table now, then you need to create a table in Microsoft Word where you kind of arrange everything very well the way it's meant to be, and all of that. I also have mean by location here. What is like, we know that three of the samples are from the river, so that's what this river stands for. And then we know that two are for the streams, which are these two. So I want to know the mean for the river, and then I want to know the mean for the stream. And also we know mean should come with standard deviation, so this second column is for what, the standard deviation. Now how can I do this when all of my data, they're actually together? What you can do is you can actually separate your data into different sub data. So what you can do, just go to home and then sort and filter and click on filter, and then you have this drop down. So you can, let's assume that I want to filter this data to the ones from, to the samples from the river only. So I will uncheck this and then uncheck this, then click on OK. So I have all of these. Now I can decide to copy these, to highlight all of these using Ctrl A, and then copy it, then create a new sheet where I will now paste. So if I paste the data here now, I know that what the data I pasted here is actually just for the river alone. I can now name this sheet appropriately as what, I can now name this sheet appropriately as, okay, river and all of that, like the river samples. So I've done all of this before though, so we don't need to do that again. So what I did is, so all the samples here are just for the river samples. Those are the three location sampling points, starting with P. Then we have the one of the streams here. I've separated the data. Another one here. Then in the individual samples for, like the individual samples for the, for in the river. So getting the mean to solve this one is, will be quite easy. So mean by location, you can use the river, data set to get all of that. Either you want to use formulas or you want to use the data analysis tab. And then mean by sampling point, also you will just use the data set for each sampling point, and then you get your mean, and then you get your standard deviation. And sometimes for your for your mean and standard deviation, you will not write it in different columns. Instead you have something like your mean, then plus or minus standard deviation. So let's look for the plus or minus sign. If you need to input a symbol, then go to insert and then click on symbol here. So you can see we have diverse symbol here. So I'm looking for the plus or minus symbol. So this is plus or minus now. So if I click on this now, click on insert, should be there already. So you can see it is here. So sometimes you will not write your mean and standard deviation in different columns, but you write it together. So you have something like mean plus or minus the standard deviation. So for example, the one we have here now, sometimes you have to record it as 17.64 plus or minus, plus or minus, okay, 17.64, then plus or minus 5.164. Okay, so that is that about that. But we know that what we need is not just finding the mean of everything. We also want to know if this mean is actually significantly different or not. So we want to know if the difference in the mean is actually due to chance, or if it is actually significantly different. For this we will be using ANOVA, because we are talking, and for the significant difference we want to check like if the mean of the different sample points is significantly different for the different variables. For this class I'll just be working with pH alone, so you can actually now try with other variables in the data set. You can try with other variables in the data set. So mean by location, and based on our previous class on pH, we should know that when you want to do ANOVA or t-test in Excel, there's a particular way your data should be structured. So I've already structured the pH data that particular way, so that the pH of each location is already listed under it. So everything here is the pH data arranged the way Excel will be able to interpret it. So I'm also going to be using the data analysis tab. Now I want to know, is there a significant difference in the mean of these different pH of the different sampling points? So I'll go to data, then click on data analysis, and this time around I'll look for ANOVA single factor, then click on OK. Now it's asking me for what? It's asking me for the input range, which will be this one, and please make sure you highlight everything. Then label in first row, yes, because I selected it with what? With the column header. Our significant level is 0.05, so that is okay. Then output range, where do I want the data to be in? I already selected the output range, which is here before, so clicking on OK, then I have my result. In my result now, I can see what the mean for the different samples. So this is the mean pH for the different samples, and I can see the variance also for the different samples. This count and some is not really, we don't really need it that much, but what is actually important for us now is our p value, then the f, then the degree of freedom. All of these are usually reported in your results table. You can also check online how to, for example, if you run ANOVA now, you can check online for APA style of how to report ANOVA and all of those things. You get more information on how you can do your data interpretation and then discussion and reporting that way. So for our business is this p value. Now we can see our p value is very small. This is 4.82 raised per times 10 raised per minus 6. So if you see e then a number, it means what? Times 10 raised to power that particular number. But this is in scientific data type, so let's change it to number. So click on it now and go to home, then from change this from general to number. You are seeing 0.00, but if you try to increase the decimal place, then you can see the number that is there. So if our p-value is less than 0.05, which is the significant level, what is that telling us? That is telling us to what? To reject the null hypothesis. And what is our conclusion? Then our conclusion will be that there is a significant difference in the pH value for the different sampling points. That is how we can analyze this data in what? In Excel. So we've talked about how to get the mean for each of the variable. But when it comes to running of the statistical test, you have to do it page by page. So we've done for pH. Now if you want to do it for maybe the sub oxygen variable, you have to create another sheet and then copy out the data for each variable appropriately and then run your test. Then you are going to get your result. So really we are looking at different sampling points only, but if you look at the data set, you can see that we also have dates. So what if you want to look at different months? I don't know if there is significant difference over different months, or you want to group these months into quarter, if there is significant difference over different quarter and all of that. We even have time, so we might want to know maybe the variables are based on time of the day, if there is seasonality during the day. So maybe the temperature is different in afternoon, like there's significant difference over morning, afternoon, evening, all of that. So you can look at the research from different angles. So this is how you can actually deal with this analysis using Microsoft Excel. So I'm going to just open GraphPad Prism and show us how to do the analysis with GraphPad Prism now. So for GraphPad Prism, the type of table that you choose, you have to choose column. Yeah, you have to choose column, and then I think we are good now. Click on create. So we have, and then we have this. So for GraphPad Prism, you might not be able to analyze it like all the variables at the same time as we are able to do in Excel. So for this, I'm just going to rename this data and then I'm going to call it pH, because for this particular table we'll just be working with the pH data only. You cannot analyze several numerical variables at the same time as we did with the data analysis tab in Excel. So for this one, I'm just going to go to Excel and just copy the pH data only. I'm just going to copy all of these, and I'll paste it in GraphPad Prism. So now the pH data is here. So I can still do my descriptive analysis. I want to know the average pH for what, for each sampling point. So I will go to analyze, and then let's see, let's click on descriptive statistics, then click on OK, and then it's asking of what exactly do we want. So we want minimum, maximum, range, mean, standard deviation, standard error of mean. If you want quartile, we can check that also. Any other one, I think I am okay. Then show these many significant figures. If you want to change this, you can also change this. Then click on OK, and then what, and then we have this, right? We have the number of samples for each location. We have the mean, standard deviation, and then the standard error of mean, the range, the maximum. We have all of that. Okay, so what if we want to visualize our mean and maybe mean and standard deviation, or the mean and the standard error? Then we can click on this here. Okay, under graph now, so we have the data table, we have this info, we have results where we have just one. So we have results. So if we click under the graph now for this pH data table, then we are going to have different options of charts that we can use. So presently we can use this chart. You can also check for other options depending on what you want. Maybe we want to go with this one now. Then so we are presently plotting mean and standard deviation. You can decide to plot mean and standard error of mean. So I think mean and standard deviation is good in this case. Then clicking on OK now, then this is our chart that is showing the mean of pH across the different sampling points. So you can double click this one to edit it and maybe call that sampling point. And then you can come here and call it what, pH. You can make this bigger. I think there are different ways to edit it. You can also edit the title of the chart. So we have resize graph here. Can make it larger. Yeah, can make it larger, and then you can copy the chart. You can copy graph and paste it in Microsoft Word. You can change the design. Maybe you don't want this black fill, can change the design. This is presently the fill. You can change it to whatever I like. So that's all of that. So this is how you can get your descriptive statistics and then your visualization in GraphPad Prism. So now we also need to do the ANOVA also, to know if there is significant difference in mean of pH for these different sampling points. So we can go to analyze, then click on one way ANOVA, and then click on OK. Then we have this. So we want to use ANOVA, not non-parametric tests, and then I'll just click on, I think we are good to click on OK now. And then we have our results. This is the p-value 0.0001, and then the summary is that it is significant, which is true, because what, the p-value is less than the significant level of 0.05, right? So now when you do ANOVA and then the p-value is significant, there are other tests that you can run, because ANOVA will actually not tell you which of the two samples are actually are significantly different from each other. So those other tests can tell you which samples are significantly different from each other. So those tests are called multiple comparison tests. So you want to compare different, they are called multiple comparison tests. So you can decide to edit or modify the test parameters. I'm just going to click on ordinary one way ANOVA, and then we are not doing repeated measure, so we don't have business with this. So but this multiple comparison, it is presently set to none. So you can click on this and say compare the mean of each column with the mean of every other column. That is what is suitable for this particular test we are running. But you can also say you want to compare the mean of each column with the mean of a control column. For example, assuming we have a particular river sample that is actually referred to as the standard, you might want to compare the mean of every other sample to that of the standard to see if they are significantly different from the standard. But because we necessarily don't have a standard sample in this case, then we can just compare the means to each other and then see what we have. Also, you can select the exact multiple comparison test that you want to use. So it GraphPad Prism always show the recommended test, and for this one it is 2 key, while there are other ones also. So I'm just going to go with the recommended test, and then I am good. I'm just going to click on OK. And then after having the ANOVA results here, then we also have the multiple comparison results here. It might look a bit clumsy, but you can see, so what is comparing each is comparing two sampling points together. So we can see that these, I don't know how to pronounce these samples. Let's just call this AS and this one AL. So we can see that AS versus AL is showing that there's a significant difference. And then another one where we have significant difference is AL versus this PF. And then another one is also AL versus PB. So that's the point of multiple comparison. Instead of just comparing everything like as a whole, is now picking two samples and comparing those two samples. So when you see that there's significant difference in your ANOVA result, you should actually do multiple comparison tests to actually know which two samples are actually significant from each other. So everything we've been doing in GraphPad Prism now is just for one variable, which is what pH. So that means if you want to run for the other, is it 6 or 7 variables, you want to run for the other variables, that is 6, 7, for the other 7 variables, then you need to do what? You need to create another data table. So just click on plus and then click on plus and then click on column again, then create, and then you have another data table. You paste your data inside and then you do your thing again. But one reason why I actually love GraphPad Prism is that for GraphPad Prism I don't need to actually do it, like I can duplicate this pH, delete the data under this pH and paste in the data of another variable, and I will still get my results, which to me is actually very beautiful. So I only need to come here and duplicate. So there are different duplicate options: duplicate current sheets, duplicate family. What you need is duplicate family, because if you duplicate family, then it's going to duplicate the data sheet, it will duplicate the result sheets, and then it will also duplicate the graph sheet. So when you duplicate family now, you need to give it a new name. Let's say this one is for the total, let's say this one is for the dissolved oxygen now. Dissolved oxygen. So I've given it a new name as dissolved oxygen. I'm just going to click on OK, and that is very good. So now I will delete the data here, and I need to go and get the data for dissolved oxygen so that I can paste it here, and you will see how how I'll just get my results for dissolved oxygen without running my analysis again. So this is the data for dissolved oxygen. I've prepared it here. I'm just going to copy it. Make sure you copy everything, please. And I'll just go to GraphPad Prism and I'll just paste it here. Let's check what is in the result sheet before. You can see there's nothing there because there's no data there, right? There's no data there. So but if I go back to this is the dissolved oxygen sheet now. If I paste the data there now, immediately without me needing to go to analyze to run another analysis, if I come here now Now we can see the descriptive analysis for dissolved oxygen. Then if you go to, then we can also see the one way ANOVA analysis for dissolved oxygen. And if you go to the visualization also, you can also see the graph for dissolved oxygen. Like, this is what I love most about GraphPad Prism. The fact that I don't need to run my analysis over and over again. If what I'm doing is similar, I only need to come in and paste in the data and I am very good. Anyways, we need to change this from pH to dissolved oxygen because we typed that in manually. And this is the end of today's class. And also, this will be the last video from my end in the FIB data analysis training. We are still expecting a video from Abefe, and then we will still have one or two videos from Oyega. It has been a beautiful experience teaching and trying to impact you guys with knowledge. I hope everything you've learned from this class actually helps you in your final year projects and maybe in your career later in life. So there will be a live class next week, Saturday. The exact time will be communicated on the WhatsApp page, and then the link to register for the class will also be sent to the WhatsApp page, and then it will also be on the training resource page. Also, there will be a test also that will be next week Sunday also. That's in October. That will be the final test. And we'll be having a graduation ceremony, or we'll be having a graduation session, which will most likely only be open to people that actually score, that have more than 50%, that's more than average, or average score, that have average or more than average in the aggregate test score. And those will be the people that would be eligible to get certificates from the training. Also, in the graduation session, plan is going on to invite two professionals to actually come and motivate us and impact us with knowledge, and for us to even learn better about data and research and everything in between. So I'll see you guys in the live class next week, Saturday. If you have any question, you can comment under this video or ask on the WhatsApp page. Thank you. Bye bye.